So the game we're trying to play with this robot, it takes place on a large field that's 54 feet long by 27 feet wide. So the first kind of goal we had to tackle here was figuring out how are we going to move this thing around the field. So that's the goal of these, what they call mecanum wheels down here. And basically the goal of these wheels is that they have rollers on them, which causes the force vector, or the force exerted by the wheel at a 45-degree angle to the rotation of the wheel to be cancelled out because it gets absorbed by the roller, which means that each wheel actually pushes diagonally. And by combining these diagonal pushes, we can actually move the robot side to side as well as back and forth, giving us freedom to move in any direction when we're playing the game. And since maneuverability is going to be such an important part of this game, as we'll see, that was a really important phase of our design, is figuring out how we were going to get the robot to move where we wanted it to go quickly. Because the game is very short, it takes place within a 2-minute and 15-second period. So then kind of moving on to this big obvious manipulator here, the basic goal of the game is to manipulate these game pieces. And they kind of look like inner tubes. And what we're trying to do with these pieces in order to score points is put them onto a scoring rack, which looks somewhat like this. And based on where we can place these inner tubes on the scoring rack, we accumulate points during the game. And depending on where it is on the rack and the different, actually the shapes that are formed, the orders that are formed by the game pieces, that actually can score as bonus points. So in order to accomplish that on our robot, we're using this, what we call the manipulator, or affectionately the arm. The arm, it contains 4 different motors. It has this kind of a shoulder motor, which lets its first joint move up and down. It has an elbow motor, which lets the second joint move up and down. It has a wrist motor, which gives it the ability to move a game piece up and down at the end of the arm. And then finally, what we've affectionately termed the claw is at the end. And this claw opens and closes, and that's what we're using to actually grab onto the game pieces. So the basic kind of concept of operations that happens here is we go down to one end of the field, use the claw to grab a game piece from the feeder, move out, turn around, run down the field 54 feet until we get to the scoring rack, and then lift the arm up to the appropriate position, use the wrist as necessary to do fine-tuning adjustments and so on. And then finally move the claw onto the rack, open the claw. The tube drops onto the rack, and then we get out of there and do this again. And that takes place for 2 minutes of the match. Basically, during the last 10 seconds of the match, we're allowed to let the minibot free onto a tower. And the minibot it's a small metal pole, a couple inches in diameter, and the minibot is supposed to run up the tower as quickly as possible. And based on the order in which the 4 minibots on the field reach the top of the tower, we can score bonus points ranging from 10 points for 3rd place to 30 points for 3rd place. To put this in comparison, tubes scored on the game rack score 1 to 3 points, depending on where they're placed. So it's a big bonus at the end of the game. Some of the cool things they've done with the minibot here is it actually attaches to the pole using a very strong magnet, so it doesn't have a mechanical clip on the other side. Instead, just this magnet is attracted to the pole, and it keeps it attached to the pole as it runs up. The other really cool thing that they've done is that they've when it reaches the top of the pole, now it's 10 feet up in the air or so. We have to figure out some way to get it back down. And what these guys have figured out is that by using a regular household light switch, like the one you'd find at the end of a hallway where you have one at each end, when a switch is triggered at the top of the pole, it actually disconnects the battery from the motors, but then closes the circuit on the motors without the battery in it. And what that causes the motors to do is they turn into generators. And as it's running down the pole, the motors generate electricity, but in doing so they take away the kinetic energy that would be generated by the gravity pulling it down the pole. So the minibot actually goes very slowly down the pole, much slower than it would just in free fall. Right. So it's completely safe as it comes back down.